Hi everyone, Miss Critty here again, and now we are moving on to topic 6-5, which is applying properties to find the area, and we're going to be using the distributive property to do that. This is probably our third look at the distributive property, and it's something that we've been reviewing a lot throughout the topics. It keeps coming back, and it will keep coming back. So just a reminder, the distributive property is when we can take a larger fact and break it up into two smaller facts. And when we solve those two smaller facts, we can add the products together, and that will equal the product of the larger fact. Now, we've already done this several times with arrays, so this is more of the same. So let's just review with the arrays. Again, we keep one factor the same and then break up the other one. So if our original equation was 4 times 8, we can break up one of those factors. And in this case, we're breaking the 4 up into a 2 and a 2, and the 8 across stays the same for both of these smaller pictures. So our 4 times 8 now becomes a 2 times an 8 here, and a 2 times an 8 here. 2 times 8 is 16 on both sides, and when we add those together, we'll get 32. And of course, 4 times 8 is indeed 32. So now we're going to be using it with the area model. And in this case, we can look at the original rectangle and find the length and width of the original rectangle, which would be that 8 across the top times the 3 down the side. And in this case, one of the factors has been broken up, and it's showing the 8 has been broken up into a 4 and a 4. Times that 3. I'm going to change that color of the 3 so it stands out more. Times that 3. So now we've got 4 plus 4 times 3. And when we go to make our two smaller equations, we know we're going to have 4 times 3 plus the other 4 times that 3. And we notice that that 3 did not change, so the 3 is in both of my equations, and the 4 is in both because the 8 was broken up into that 4 and 4. So what I want you guys to do now is pause the video and give this one a try, and try to set it up just the way we have it here with the original equation, then showing what factor has been broken up, and then the two smaller equations. And when I go and solve this, I get a 12 and a 12, which equals that 24. So go ahead. I'm going to finish solving this one. Equals 24. 12 plus 12 equals 24. So go ahead, pause the video, give this one a shot, and then press play so that you can check it along with me. Okay, let's take a look at this one. So I can see that the original equation is 7 as the length and 5 as the width, 7 times 5. And in this case, my 7 was broken up into a 4 plus a 3 times that 5 that's staying the same. So I know that that 5 is going to appear in all of the equations. So here I will take my 4 times my 5, and then my 3 times that 5. And at the end, I add them together. So 4 times 5 is 20, 3 times 5 is 15, and when I add them together, I get 35. Now, usually we would never actually use the distributive property for a fact like 7 times 5, because that's very simple to solve, even if it's not memorized, and even for 8 times 3. But it's still important to be able to show the distributive property using any of these facts. And in this case, we're doing it for the area model. So we've broken this rectangle into two smaller rectangles, a 5 times a 4, and a 5 times a 3, which matches up with what we have right down here. And then again, we would have 35, I almost forgot to label, 35 square units and 24 square units. Labeling is so important, so please make sure that we are always doing that. So that is what 6-5 is all about, using the distributive property to find the area. So you'll always be taking a figure and breaking it down into two smaller figures, whether they're squares or rectangles, finding the area of each of the smaller rectangles or squares, adding them together to find your total area. So remember, if you ever need to rewatch the video, you can, and you can go ahead and start practicing this topic. Have a great day, and I'll see you back for topic 6-6.